A couple videos ago, we talked about conservation of energy. The fact that in any closed system, the mechanical energy would stay constant no matter what happened. But now, it's time to talk about conservation of another quantity. Conservation of momentum. So, let's go about it, and let's move on to the video. Now, this is very similar to conservation of energy, as a conservation of something basically just means that the initial momentum, Pi, is equal to the final momentum, or that the net change in momentum is zero in a closed system. Now, what is momentum? Well, momentum is mass times velocity. So, mv1 is equal to mv1 plus m1v1 plus m2v2 and so on is equal to m1v1 prime and so on and so on. Now, this system will come in very handy in a later thing where we talk about collisions. But the biggest thing for now is that what we're going to do is we're going to examine what happens when we have these different terms, these different velocities. How can we tell what the final velocity is? Now, today we're going to be now that is pretty much the entire focus of collisions. But today we will not be covering collisions. So, what are we going to do? What's going to happen normally is we're going to have an initial object at rest. Now, this means that one of our sides is going to be equal to 0. And then this will also equal the final momentum. But you can't have two positive velocities. So what we're going to have one positive and one negative velocity. Or one positive momentum and one negative momentum. And again, what this does is this reinforces the idea that momentum is a vector. It is not a scalar like energy. That's also what makes it different. It is a vector. Now, so we know momentum is a vector, we know that the final or an initial momentum can both equal 0 while their individual components also have momentum, and that's a very interesting consequence, and it's actually what helps rockets go into space along with many other things. So, let's move on to an example. Over here we have our first problem. Now, I did say that that we would mostly be covering problems that would have zero initial momentum, but the reason I'm covering this problem is it also teaches another very important lesson.